This is from NEST 2019 second shift. Okay, NEST 2019 second shift. For alpha greater than -1 and beta greater than -1, the value of the limit as n tends to infinity, n to the power beta minus alpha, 1 raised to alpha plus 2 raised to alpha up to n raised to alpha upon 1 raised to beta plus 2 raised to beta up to n raised to beta is beta upon alpha plus 1, beta plus 1 upon alpha plus 1, alpha plus 1 upon beta plus 1, and alpha upon beta plus 1. Okay, now when I looked at this problem for the very first time, I thought, let us choose alpha and beta to be 0. Okay, let us choose both alpha and beta to be 0, and then what do we get? Limit as n tends to infinity, because they meet the requirement stated there, alpha greater than -1 and beta greater than -1. Okay, limit as n tends to infinity, both are 0, so n raised to 0, so that is 1. And here, because the powers are all zeros, it will be n upon n, so the final answer will be 1. Okay, the final answer will be 1. And if we check for the options which have only beta and only alpha in the numerator, they are definitely ruled out because they are giving us 0, and our limit is definitely not equal to 0, it is equal to 1. Okay, so a and d are gone, Now what we can think of is, let us select alpha as 1 and let us select beta as 0. Okay, let us select alpha as 1 and let us select beta as 0, and by doing that we will get n tends to infinity, alpha is 1, right? Alpha is 1 and beta is 0, so this will be n raised to -1, or let us write it as 1 upon n, into alpha is how much? 1, right? Alpha is 1, so that would be the sum of first n natural number, so n into n plus 1 upon 2, right? N into n plus 1 upon 2. And how about the numbers in the denominator? Beta is 0, so they will sum up to n, right? Okay, so we can take that half outside, n into n plus 1 in the numerator and n into n in the denominator. Okay, so how much will that be? The limit if you take nn will get cancelled, so it would eventually be 1 by 2 into limit as n tends to infinity, 1 plus 1 upon n, so that 1 upon n will go to 0, so it will be 1 upon 2, and you just need to check for the options whether it is C or B now. Okay, look, what does B give? Alpha plus 1, so 2, beta is 0, so that's 2. So is B right? No, B is not right, so correct option is C. Okay, this is one way to solve this particular problem. Okay, this is one way to solve the problem, by wisely choosing the values of alpha and beta and eliminating the options. Okay, but suppose you did not find, you are not able to find, you could not find appropriate values at the time of the exam. Then what would you do? Okay, then what would you do? In most of the cases with n tending to infinity, and there is a possibility that you can write the given limit in terms of summation notation, you have to use the definite integral as limit of sum. Okay, and so let's see if that works here. To do that, we will do the following. Okay, let me write this as n raised to beta upon n raised to alpha. Which one? N raised to beta minus alpha into, in the denominator I can write summation as r goes from 1 to n, r raised to beta, and in the numerator I have to write the same thing, with alpha as our power, 1 to n r raised to alpha. Okay, now let us adjust here. Okay, let's adjust. It's convenient to send n raised to beta in the denominator's denominator and n raised to alpha in this summand's numerator. Okay, so it would be summation r going from 1 to n. What raised to alpha will I write now? R by n, and in the denominator also I need to write the same thing but raised to beta. Okay, I hope you have understood this step, and now comes the main part. Okay, now there have been questions in isoperative test where it was a definite integral with limits 0 and 1. Okay, now look here. If I am integrating some function f from 0 to 1, okay, can I write it in terms of the limit of a sum? Yes, I will say limit n tends to infinity, limit n tends to infinity 1 upon n into f of r by n. Now if you don't understand this, look here, h in our usual notations, which is b minus a upon n, is now 1 upon n, and a is 0 and b is 1. Okay, now what is missing in that particular expression inside the limit? 1 upon n is missing, so let us do it. No harm in doing that because we are doing it in the numerator and in the denominator. That's the key step, multiplying the numerator and denominator by 1 upon n, and we write, what can we write? Well, now we assume that both numerators and denominators limit exists, and we can say it is 0 to 1. Can you recognize the function for me? X raised to alpha. And in the denominator, what would be the function? X raised to beta. What is the limit now? Value x raised to alpha plus 1 upon alpha plus 1. Forget about the limits because, well, limits as in upper and lower limits, because 1 will give you 1, 0 will give you 0 upon beta plus 1. So beta in the numerator, alpha in the denominator. Right? Beta in the numerator, alpha in the denominator, same option. Got it? Okay. Fine. So which method do you find easier? First one or the second one? Sorry? First one is, if I were the student, I would definitely go for the first method. There's nothing, you just have to substitute and eliminate the options. But I think, well, me being a teacher, I will recommend you to go through both the methods, so you'll have at least options open in front of you. Because the first one, method 1, if you are habitual of doing that, then the numbers alpha equal to 0, beta equal to 0 or 1, 0, they will appear to you quickly. But if you are not habitual with that, then you can definitely go for second method. And also remember that whenever you see a structure like this, limit of something tending to infinity, and there is a possibility of expressing the limit using a series, always go using summation notation. Think about definite integrals. Okay, all right.